Imagine two identical auto repair shops. Same square footage, same technician headcount, and the exact same daily car count. Despite these physical similarities, one of these businesses consistently generates significantly less revenue than the other. This split screen tracks the disparity. On the left, a struggling shop operates at 58% bay utilization, yielding a $155 effective labor rate. The top-performing shop on the right hits 96% utilization, producing $340 per bay hour. That $185 hourly delta extrapolates into a $444,000 annual revenue gap for a standard 3-bay shop. The limit on a shop's earning potential is rarely the mechanical skill of the staff. It is a function of the workflow architecture. Optimized job management functions as a sequential supply chain, moving through 4 critical nodes: intake, routing, parts, and authorization. We can observe this system in action with a complex, high-severity transmission diagnostic. This 2018 Ford F-150 is a prime candidate, as it is frequently affected by the well-documented 10R80 10-speed transmission failure. This defect physically manifests as harsh shifting between gears and a distinct multi-second delay when engaging reverse. Profitable resolution of a failure this complex requires a digital management pathway that is just as rigorous as the mechanical repair. The timeline begins when the F-150 arrives for a routine 30,000-mile service, a simple oil change and tire rotation. In an optimized workflow, the technician initiates a standardized digital vehicle inspection before any requested work begins. Part of this protocol includes a mandatory test drive to evaluate real-world performance. During the drive, the technician shifts into reverse, experiencing a 3-second lag, followed by a violent lurch of the cabin. The failure is visible. The tech immediately pulls the Adact's learning transmission codes and records a video of the delayed engagement to document the fault. These findings, including fluid condition and fault codes, are appended directly to the customer's digital service file. By structurally forcing the discovery of latent mechanical issues, the DVI process transforms a low-ticket maintenance visit into a high-value diagnostic event. The technician identifies the failure as a 10R80 valve body issue, a high-severity repair. If this job is routed ad hoc to the first available intermediate technician, the shop risks an operational bottleneck. An intermediate tech will likely exceed the allotted book time, occupying a bay that should be turning over other vehicles. Skill-based routing prevents this by cross-referencing job complexity against specific technician certifications. The algorithm evaluates the floor, actively rejecting junior technicians for this specialized repair and routing the packet to the master technician. This ensures the repair is performed by a specialist capable of a 1.3 times book time efficiency rating. Deterministic routing protects the master technician's time for complex work, while ensuring junior techs remain productive on standard maintenance. Securing approval for a $2,000 transmission repair is a high-friction transaction. Explaining a complex valve body failure verbally over the phone often fails to convey the severity of the issue. Data shows that verbal phone authorizations for unexpected, expensive repairs convert at only 38 to 45%. This is the result of informational asymmetry. The customer lacks the visual context required to authorize a major expense. The optimized solution sends a digital estimate containing the recorded video of the transmission malfunction and the accompanying diagnostic data. Providing this visual proof causes approval rates to climb to 89%, with many customers authorizing the work in under a minute. Digital evidence provides the transparency needed for a customer to understand the necessity of a high-dollar repair. Even an authorized repair order is stalled if the physical parts are not in the building. Manual sourcing creates friction, as staff waste time on phone calls or discover missing components only after the vehicle is disassembled. Once the estimate is digitally approved, the system automatically parses the required materials. It verifies 12 quarts of Mercon LV fluid in local inventory and simultaneously triggers an external purchase order for the OEM valve body. By eliminating emergency shipping fees, preventing duplicate orders, and stopping unbilled parts leakage, this integration can recover up to $5,500 in monthly overhead. This allows for a strict operational rule. The technician does not begin the repair until the complete parts manifest is physically verified. When this system is applied across every bay, the work-in-progress dashboard reveals a synchronized ecosystem. The shop has successfully turned a routine oil change into a fully authorized, high-margin transmission repair. This was achieved without bottlenecks, no phone tag, or bays waiting on parts. Transitioning to this model requires a mandatory DVI process, a documented skill matrix, and an integrated parts API. Adopting this architecture allows a shop to move toward the $340 hourly labor rate seen in top-performing facilities, securing revenue that is usually lost to simple inefficiency.